So the next session here is a panel discussion, immersion cooling challenges across the ecosystem. So I will start actually with just asking you, Rolf, looking at the challenges here with immersion. I mean, we hear success stories, we hear stories, right, of all the benefits of immersion, but here you specifically then been focusing the immersion sub-project, right, on addressing challenges. Can you bring up some of the history of that?
Yeah, absolutely. And just for the record, this is going to be an interactive session with all of you as well, right? So we're going to be involving every one of you throughout the session. We're going to be doing some panel introductions first, but then after that we're going to open up the mics as well, so we would love you to contribute to the conversation as well.
And there's a mic on each side here.
Yeah, exactly.
So please line up.
So nice that you asked, because challenges is indeed something that could feel a little bit awkward to talk about, because yeah, these events are all about, all right, what's great and what's fantastic and why do we even do all this, and that's all fantastic. But in order to progress these kind of technologies, one of the key elements that we'd like to focus on is why would you not want it? And you know what? There's plenty of folks out there who do not believe that immersion should be done, or who may not be comfortable with immersion cooling. And that's something that we find of super high interest in our community, because it helps us focus on what type of things we need to overcome, what type of things we need to resolve. And
like the roadmap that we were talking about.
Like earlier. The roadmap we were talking about, indeed. And that's exactly where this comes in. So we had these kind of challenges, interactions, and challenges, engagements. At some point we had a call regime where we had a monthly get-together to discuss, hey, what is in the way? We decided to transfer that into a half-yearly conversation with the community at the events to make a bit of an inventory, because it helps us focus, right? So to give a couple of examples of how we've used some of the challenges insights, immersion requirements is one of the foundational documents in our community, where we set the baseline, the minimum level or that technologies need to comply with. And that is all derived from, okay, let's explain to the industry what is the minimum need, right? Based on feedback from the community, hey, what do we need to comply against? How can we start generating standards? Other examples are signal integrity, right? So we've seen now a lot of attention already to signal integrity. There's more to come in the next, after the break. Because signal integrity is somewhat of a mysterious thing relating to electrical fields, and it feels very complicated. It can be very, it might feel daunting.
Not that mysterious.
Well, if you're an electrical engineer, it isn't, right? And so we decided, okay, let's focus some of our work efforts on these kind of topics. And in the same way, we've dealt with total cost of ownership, oxidation stability, material compatibility, which eventually has led into reliability as a whole different pillar within the community. We've set up industry liaison teams, or an industry liaison team to help with standards based on community feedback. We focused on safe handling because somebody asked a question in the audience about, hey, has anyone ever considered safety? How do we deal with these chemicals, right? And all that has transferred into work streams and work efforts. And a really nice example of one of these challenges has been, I think it was 2 years ago, when we had reports about a potential ceiling for immersion cooling. Some people were saying, okay, yeah, immersion can only deal up with thermal densities up to 500 watts. And
for
everybody,
for
single-phase immersion cooling, right? So that made a lot of us frown and think that now, that is not right. So I think that was one of the great examples where the entire community got together, and within half a year time, we had the first demonstrators up and running, even here at the Global Summit, of densities that were going way beyond the kilowatt, and that really proved, hey, we haven't even scratched the surface yet of the potential where immersion can go. So these are some of these successful. So we take these challenges items incredibly seriously because it feeds directly into our roadmap for the next couple of years. Right?
Yes, and we're looking at expanding that roadmap, right? What are the challenges? We also have a few things that are currently in progress, right? So if you attended the 8 o'clock meeting that was talking about the immersion community, we had OCP alignment, right, as one of the support structures to the immersion project as well. We're still working on that in order to find a structure of how we make sure that all the liquid cooling efforts that are going on in also other projects, make sure that they're aligned with the cooling environments and including immersion as well. As well as one of the things that has come up multiple times is just we need a lab for testing all of this. It's great that you guys put all of these requirements together, but where do we test it? And that's where we also work in progress with the Southwest Research Institute that you also heard about this morning.
So,
yeah, with that history.
Without further ado, we have our technical committee chairs. We've invited them. They're sitting over here. And guys, would you mind just giving a very brief introduction about who you are, what you do in your day job, and especially your involvement here as committee chair within the immersion community? And let's just start with you, Samantha.
My name is Samantha Yates. I am a principal at engineer at Intel, and I've been doing immersion reliability testing at the component, server, and rack scale for about 2.5, 3 years now. I think that the community has seen some of the results of that effort. I think what my committee is focused on is some of these ecosystem methodologies that we developed for both material compatibility, systematic material compatibility standards methodologies, and results analysis, and then leading into how do we assess server and rack level reliability that is consistent and standardized across the industry. And a lot of the challenges is having all of the stakeholders that have a critical role in those different areas to contribute to this reliability discussion, because everybody's like, well, I'm not a reliability engineer, what do I know about it? I don't need a whole lot of reliability engineers. What I need is your input on, hey, I have a component, I make this component really, really well for air, but now I want to know how to do it for immersion. Are the things we develop working for you, or do we need to shift? Do we need to think of different ways to do it? So even if you're not a reliability engineer, I need people who are experts in their components and their servers.
Thank you.
Thank you.
Austin, a quick intro?
Yeah, so Austin Hypes, I'm the Chief Technologist and Vice President of Engineering at UNICOM Engineering for about the last 22 years. For about the last 6 of that, we design immersion servers. So we design, integrate, deploy, and do the warranty support. So a lot of expertise there, especially in working with Tier 1 manufacturers. My role is the technical committee chair for ITE and immersion. So that's where we focus on things like the signal integrity, the advanced cooling techniques, and most importantly nowadays, the ITE design guidelines, which we're currently working on to help standardize all this and help the community know, how do I design, test a server for immersion specifically?
Awesome. Kris.
Kris Fletcher. I might be one of a handful of chemists in the room. I work at BP Castrol. I'm the OEM liaison for our data center cooling team, liquid cooling team. I've been doing product development for about 20 years, and I've been working in the data center cooling space for the last 3 years or so. I lead the fluids committee, and we're concerned with pretty much the fluid. What happens to it whenever you immerse it? What does it do to the things that you're immersing in it? How do you handle it safely? How do you look and understand when it begins to degrade and needs to be removed from service? What do you do when you remove it from service? One thing we'll be addressing is, how do you determine if a product is fit for purpose? So fluid specifications for the different types of single-phase, two-phase immersion, cooling applications, as well as the different fluids that can be used in single-phase immersion.
Awesome, thank you so much. And Amy?
Hello, everyone. I'm Amy Short. I am an Executive Officer of Advanced Data Center Technologies at Denvr Dataworks. Denvr Dataworks is an AI neocloud, but we're vertically integrated, so we have a hand in design and operation all the way from the infrastructure up to the cloud. I lead the actual immersion solutions community, and within that are some work streams that relate to requirements, so setting general guidelines and minimum thresholds, guidance, and justification for all of those different items. Total cost of ownership, which allows people to make smart business decisions. It's not just an immersion TCO model. It actually is agnostic to cooling environment. So if you haven't checked it out, check that one out. Hardware management, which really focuses quite a bit on interoperability, failure mode and effect analysis, and also power distribution for immersion cooling.
All right, thank you very much. So with all of you present here, we've got deployment and IT equipment, we have reliability-focused IT equipment, but also adoption. I mean, you're one of the end users in the ecosystem, right? So you're familiar with how you intend to use or how you should be using immersion and how that can contribute to business. Right, but we also have fluid chemistry and a lot of knowledge about how to deal with fluids. And we're going to start the conversation now. We're going to focus on why would somebody not? So we're not going to do the pitch on, hey, immersion is great, immersion is fantastic. I really want to get into what is in the way. Why should you not? What is against immersion? And please, guys, the microphones are here. I'm going to start with the panelists, but we would love to gain your insights. As soon as I see somebody standing at one of the microphones, we're going to cut the panel short and we're going to give you the stage because we value your input a lot more than ours because we're in the midst of this, right? So the external input and feedback, please do feel free to step up and join the conversation. The question that we're going to be opening with is I'm going to put you guys up with a little challenge. I would like you to come up with 3 reasons or 3 challenges.
Yeah.
But 3 reasons why immersion is going to be more difficult for you to deal with from your own perspective, from your knowledge, from your experience set.
Thermochemical quality and reliability. It's a new failure mode. It's not something that the industry is used to building servers to assess. I think the ecosystem understands, hey, I build a server, here is the validation methodology I go through to make sure that that service is reliable in the data center, in air, and even, I think, in cold plate. Still a work in progress, but better than immersion. There's a huge cost adder and there's a huge knowledge gap. And okay, now we have to understand these new failure modes and we need to test these new failure modes. There's a knowledge gap and then there's also a cost adder in taking your server and understanding, is it going to be reliable in this environment when it hasn't been natively designed to do so? And that isn't insignificant in the capital investment to deploy immersion. And if you don't have the expertise, you don't have partners with the expertise, and you don't have the money, then this may not be the most optimized solution for you.
So if you had to make a top 3 of just one-liners. Yeah. This is hard, right? That's because we're so entrenched in it. So I completely understand that this is a difficult question to ask. So what are the 3 things that you would say, okay, these are the 3 top items that you get confronted with?
Cost, and cost.
Cost.
Time, schedule. I mean, when it comes to testing, I think every reliability engineer always hears that. Well, that's going to cost me money and that's going to take time. That doesn't. That certainly applies here. Is that testing to make sure that you have a immersion solution that is meets the quality and reliability goals takes money and time. It's not.
Okay.
It's
so
not too. But it's too.
Cost, time, schedule for reliability testing.
For deployment, for reliability testing, to say that you will be successful in your deployment.
Okay.
Awesome.
So you know I'm going to start with signal integrity, just because it's different. But beyond signal integrity, and we got some good stuff after this and after lunch on SI specifically, but beyond that, it's regulatory compliance. There's not a lot of good test methodologies through the standard regulatory test specifications that we're working on. And then standardization. You can't take every server, put it in every tank with every fluid, and that can be confusing to customers that are new into the market.
Kris.
Overcoming the fear of using these kinds of fluids and how to handle them safely within a new environment would probably be number one. Number two is it's going to be relatively easy for someone to bring a product to market, so we need to make sure that they're bringing a quality product to market. So then establishing specifications that ensure fluids meet performance expectations, and then how do we test these fluids to determine that they are meeting these performance expectations? So there's a lack of readily available testing in the conditions that we need to evaluate these fluids.
Awesome. Amy, and after that we're going to go straight to the mic after you. So please, because I'd love to get your views first, and then we'll move to the room.
Okay. Yeah, I think from my experience, a lot of things come down to cost per megawatt. How much do you have to pay for the entire deployment? So cost optimization is number one. The second is the options. And it really is just a supply chain thing, right? If I have a customer that requires certain types of hardware and certain types of networking, certain types of storage to meet their needs, I need to be able to have those options available. Or what I have to do, and what I have done, is work with partners to create that option. Not everybody has that choice or desire. The last I think is de-risking across the board. When you implement something new, there are a lot of boxes that you have to check off. Things like safety, things like compliance, personnel training, those are all must-haves. And that's something that a lot of people in the data center space don't have a good familiarity with for liquids to begin with. But that's where they can lean on their partners.
Awesome, fantastic.
Thank you.
So we have the first question from the audience. Fantastic.
Dale Sider, Lawrence Berkeley Lab. I think the fact that there's no multiple vendor solutions that then limit procurement to a single vendor is a huge problem. I mean, many agencies can't procure, or it's very difficult to procure a sole source with only one vendor and with no substitute. So we need some interchangeable components.
So, Dale, if you don't mind me asking you for a little bit of more specificity. So, because there are multiple vendors out there, is the challenge that these vendors have different style products and they might work slightly differently?
Yes.
Or is it just a general lack of choices that we still have in the market?
Oh, no, I think there's plenty of choices, but they're all proprietary. So, yeah, it's the fact that there's, you know, once you zero in on one vendor, it's that tank, that style, I mean, that size, that material in the tank that's proprietary.
So is that part then of, if we say standardization is lacking?
So
Yeah.
are there specific elements that you would like to see specifically geared towards standardization, like a form factor or a size, or maybe the location of pipes, or anything that you might think of?
Yeah, I think form factor would be a major one. I mean, similar to, say, the rack design in data centers. You know, every time we procure, say, a cluster, we're not going out and buying a new rack. We're using, you know, existing racks that are standard. Yeah, so yeah, form factor is important.
So form factor. So is that from an approach, from a facility point of view, so that you know where to put your pipe connections and what type of load bearing and what type of physical space you would have to carve out? Or is would the challenge also be to go into how the tank is set up internally in terms of fluid distribution, or because there's a lot of variation in methods there as well. Is that less of a concern?
I think the concern is things like needing replacements, you know, an expansion of your system. You know, if the vendor that you selected the first go around either isn't competitive or isn't in business anymore, what do you do? Especially, say, with spare parts or replacements or expansion. Mm-hmm. So standardization where, you know, you can start with 10 tanks and add 5 that match. You know, the manifolds might be already set up. That's the type of thing that's needed.
Anything that any one of you wants to ask in addition to this to help specify this, or do we feel comfortable with this feedback?
think it's good.
I don't disagree. You've been telling me that I've been telling you for ages that I want tanks and
Oh, we all want that.
cold packs and air packs to all interoperate together.
Yeah.
So
Yeah.
that's very accurate.
Yep.
One thing that I would like to say is that all the things that we've published into the community, all the guidance documents, all the requirements and specs, everything that exists today is the result of the community volunteering their time and insights to create that guidance. We do have a foundational document, which is called the Immersion Requirements. It sets a base goal for all the components that might be found in the system. The intention of that document is to help justify what are the minimum requirements or thresholds that different equipment need to make, but it's intentionally flexible. And the reason why is we want people to be able to innovate long-term and have an evergreen initiative on top. So the normal process that we actually follow to build on top is to say the requirements is a foundation. It covers everything. However, there are individual opportunities for specifications to be drafted on top. So a specification like Kris mentioned based on fluid, or like Austin mentioned based on IT equipment design. Those get very specific into the details of what is required for that specific component. What I'll say is that we're still in relatively early days as a community in drafting all of the specification documents. We do have a very robust foundation and requirements. So we also have a hardware management group which focuses on interoperability. And I know you didn't mention this specifically, but one of the challenges that I heard you say was that you want to be able to interconnect multiple parts from multiple vendors, and you want them to all work cohesively within your data center. That's something that's an ongoing initiative, but what I'd invite the community for is if there are components of need where you want us to focus our efforts to create individual-based specifications to help standardize some of those key components, then let us know.
Yeah,
Let us know and contribute.
Right.
And that's also
you can
what
say
we
it's
have.
a long-term need, but the question was, what's holding back
Exactly. No.
rapid deployment?
Absolutely.
And this is one of the major things. I mean, look at it from the customer standpoint, not from your proprietary standpoint.
Correct.
Yep.
And this is great, and I think this would. I think the timing is right for this as well, Dale. When it comes to starting the work on generating a base specification that outlines these kind of references, right? I think that's great input. All right, next.
Morning, Ralph. Steve
morning.
Hammond, NREL. I think you're missing a bit of human factors. It came up yesterday, the serviceability. There's some perception of an ick factor. Huge proponent of liquid cooling, been involved for over a decade, but immersion, serviceability, what's the turnaround time if you have to replace something, right? To get something out, drained, put it back, right?
Yeah.
So, and floor loading, right? They tend to be heavier. Can you get that into a legacy data center? We couldn't deploy, we had an early system that was immersed. We couldn't do anything that didn't involve some drips. We had an absorbent pad, right? So we used to say deploying immersion kind of depends, so.
So can I translate this into providing more clarity about time to repair, for example, and potentially creating some reference designs for service tooling like lifts and specifying materials that would be needed? Is that?
Safety standards.
If something's out, from the time you get it out, when can you put something back in? Or, you know, if you replace it?
Is that part a challenge for supply chain as well, of
Just
getting the parts?
Operationally.
So you're talking more for like operational tech side? Because I think there's also some best known practices. And unfortunately, I think Austin would also say, and we've been doing a lot of the work, is I agree. It's been a learning process and iteration. And Austin, would you agree, like some best known practices on how to pull a tank out, how long you let it drip dry, how you interact with it?
There's several work streams working on this. So IT design guidelines is, of course, going to be addressing that. There's also the fluid cleaning guidelines that are almost complete. Both of these help address it, but specifically to the time involved, and I speak to this as as a supplier who has thousands of systems deployed for multiple years. Yes, it does take a little longer to service. There's typically a draining time, could be anywhere from 10 to 20 extra minutes. There is a little bit of cleaning involved to make sure that the replacement component, you don't have dielectric fluid in. But the failure rates are also so much lower that when we look at it on more of a 5 and 6/9 reliability, total uptime hours, it's already been demonstrated that you are servicing the equipment so much less often that your total uptime in a data center deployment, with hundreds or thousands of servers, is actually better, even with the slightly longer service time for a component.
Let's try not to solve the challenges here as a panel, right? We're here to really create an inventory of
We
input.
agree
And
that it's a
yeah,
challenge, yeah.
absolutely.
And I think that the question I would follow up, and I think what I'm hearing from you, is that we have a lot of internal knowledge how to do that when we've been doing, but I think, am I hearing from you what you're actually asking is that guidance that those of us that have been working with it actually publish that community, how to drain, recommended times to drain, types of apparatus to have a drain, like we have specific tables to let it drain and catch the fluid. Is that the type of guidance you're looking for, is a specific serviceability, best known practices?
I would say a recognition that the human factors plays a role in adoption, right? Because you've talked about all these very specific, very technical things. You're all in your little bubble addressing, and that's great. That's needed. But also there's a human factors element. That's all.
And
I think that's great.
it will
Yeah.
require a
awareness,
completely
right?
different level of housekeeping to ensure that you don't create slips because of the drips.
Exactly.
And
Yeah.
a lot more.
It was just, and I'm playing devil's advocate, right? You wanted some challenges, so
That's exactly what we're
That's
looking for. So
perfect.
great,
That's
yeah.
perfect.
Keep it going. Keep it going. Think of more of stuff like that, right?
What he's
I've
saying
got,
is
I've got 10. I just don't want to down.
Oh no! Please bring more.
what you're alluding to is humans are not reliable, and I will be the first to agree with that.
Absolutely. Okay. Yes. Please bring it
I'm
on.
Kim, University of Maryland, but I also work with ARPA-E, Department of Energy. We've heard a lot about single-phase immersion. There are a lot of challenges there, but what about two-phase immersion? What are the challenges associated with that? And how come there's no representation on this panel for two-phase immersion?
So,
Yeah.
So first challenge I'd say on two-phase is cost. The majority of the two-phase fluids are significantly more expensive. It's not saying they don't work well, but it can be significantly more expensive to initially deploy. So that's an area that definitely needs focus on compatible fluids at kind of a lower cost per liter. And then, they are more complex systems. You have to capture and condense that vapor, so they're typically closed systems, so that can make a little bit more complex of an environment, and kind of that initial upfront cost can be higher.
And I'm going to add that they're a little bit more kinetically energetic. So a lot of the single-phase hydrocarbons that I've been working with, they're more forgiving. We still have contamination, but they can handle higher levels of contamination with less sophisticated filtration technologies and not demonstrate any long-term reliability risk due to those low levels of contamination. You don't have that much guard band in two-phase. So one of the operational complexities to maintain reliable IT equipment is the filtration strategies with two-phase fluids have to be very sophisticated. Your control of your contamination has to be incredibly tight. And that adds an additional layer of complexity and challenges, going back to the human knowledge. Humans aren't reliable to maintain those systems and operate them over their service lifetime. Can it be done? Yes. Does it have additional challenges? Yes.
Shouldn't we also focus, so when we're talking about the human element, as Steve has just suggested as well, I think it should also be about making it easier for end users and for technicians
For sure.
to work with the technology, right? To make it easier, make it more accessible, make sure that these procedures are outlined, and not so much focus on the human failure, because that's more of an engineering failure analysis, right? But when it comes to, I do agree that serviceability is like this big gray area that is very often overlooked when talking in general about immersion cooling, that we might want to be able to provide more guidance on.
I think for two-phase, though, to the specific challenges, once we address cost, which it by all means is one of them, but, one of the things in the back of my mind that I just haven't gotten enough traction within the industry is filtration. for successful deployments, I mean, I think one of the challenges for the industry, and this kind of overlaps between Amy and I quite a bit, is how do we provide guidance? How do we provide standardization for specific fluids with recommended filtration strategies? And those are addressed at both the solutions level and the reliability. So that's one of the reasons why we are standing here, is that there is a lot of overlap. But I think what I'm hearing is, if one of the challenges is cost, once you pass cost, I think you want a long lifetime. And I think one of the biggest challenges is filtration.
Amy?
Yeah, I think one of the other things that hasn't been mentioned that is very, very relevant for two-phase and single-phase halogenated fluids is the regulatory outlook as well. You want security of your supply chain. We talked about legacy equipment getting replacements and spare parts. Fluid losses are sometimes significant with two-phase systems because they inherently are vaporizing. You want to be able to top off your system at regular intervals. If that fluid doesn't exist anymore, then you might have an issue. The regulatory outlook is evolving quite quickly for those two-phase fluids. So one of the things that I know we're talking about problems and not solutions, but we do have an industry liaison team. We do have a newfound focus on compliance. I think that we don't really have a strong focus today on the two-phase regulatory outlook, but that certainly is in scope as well to help inform people that are looking to make decisions about their equipment across the board of what the regulatory and compliance outlook looks like. You don't want to make a major investment in equipment that is at regulatory risk.
I fully agree that you don't want to go to two-phase if you can use single-phase. But if we look 5 or 10 years down the line where you're going to have chips that are going to dissipate 3,000 watts or 5,000 watts, perhaps, single-phase may not cut it.
Yeah, so what we're not saying that, hey, don't use two-phase immersion, right? And that's something that from the beginning of the immersion project as well, we've been wanting to make sure that obviously, this is inclusive, right? This is single-phase and two-phase. We have had less participation from the two-phase community. And that's why you see mostly single-phase immersion here.
And this is an ongoing challenge for us as well, right?
It has been from the beginning, really. So, we can encourage two-phase solution providers, right? Please be more active and to set up those work groups that are needed in order to address some of the challenges that we see.
Okay.
Yeah, and also to just speak to that, I mean, we're not burying our head in the sand here. It's ever since that the PFAS discussions globally started occurring, we've seen a simple retraction from two-phase participation for many reasons, and a lot of that relates to PR and the potential exposure, the reputation that PFAS has. From a technology perspective, I 100% agree with you that two-phase immersion cooling has huge benefits, it has a huge potential, and is super relevant for the ecosystem. There is this reputational aspect that comes to it. What I would really like to impress upon anyone who's working with two-phase, here within OCP, don't worry about that type of PR exposure. We're working on future technologies, whether it takes off or not. That is not up to us, not us as OCP. We really try to pull everything in. We go out of a way to extend our capabilities, to embrace two-phase inputs. But we need two-phase expertise to step up.
We need a two-phase community. Yeah.
Exactly, to participate in these calls and to provide the perspective, okay, yeah, this is how this is different in two-phase. And this is what we're dealing with these two-phase fluids when we're talking about filtration or material compatibility. But as long as we don't get it into the community, it's not going to end up in our papers.
And I'm going to agree with Rolf, because right now one of the big gaps on the material compatibility and component compatibility is we're trying to put a two-phase section in there, but I have new two-phase contributors to say we have ideas, but ideas can be really dangerous if you don't validate it with people that are experts. So that's where, two-phase experts, please, if you're a two-phase expert and you want to contribute to material compatibility, I need you desperately, because we're just kind of guessing on some of the two-phase. We're trying to, but I don't have any experts.
And that's something that it's just an inherent limitation of us as a community, because all the work that we do It's driven by the participation.
Yeah, of the
That's
volunteers.
simple.
Yep.
Do you guys mind
So
if I?
we have a next person.
Well, just real quick.
Let's.
I was going to add to this conversation as a two-phase expert, but
Awesome.
yeah. And
Fantastic.
Thank you. I'm Steve Pignato. I worked at 3M for 33 years with these fluids. And
Great to have you here.
when all this started, all of the stuff that 3M was doing on two-phase was all under NDA. So coming out in the OCP community was not going to happen, okay? So definitely apologize, but I'm now with Standard Fluids, and we're going to be involved.
We would love to get your participation.
you.
Yeah, please talk to
Please
us.
sign up.
These are the committee chairs. Please join them and reach out to them. We have somebody else who was waiting in line. Please go ahead.
So my question is about the sort of the limits of thermal performance for immersion, both single phase and two phase. So now we're getting emerging applications where like local hotspot heat fluxes can get as high as like 500 watts per centimeter squared. So in one of your talks yesterday, you mentioned that in the future there may be hybrid solutions with cold plate and immersion. But just sticking to pure immersion, could you speak to sort of what the projected limits you may see for thermal performance, and especially with regard to like high heat, local heat fluxes?
I think, Austin, you've done some work with this, right?
We've
So
done
you
quite a
might
bit of
wanna-
work, and so has the work stream, for advanced cooling technologies. But I can say without violating NDAs that there is nothing we see on a roadmap today that cannot be cooled with some of the basically the forced flow technologies, the targeted flow technologies. The local heat flux, that's more of a TIM issue, because it's just about very quickly spreading it. There are ways to do that. There are many ways that have been shown. So it's not saying we'll never hit a thermal limit. We have not found it yet with practical silicon, and that includes things that we know are coming up in a few years. It's just like with air-cooled systems or with cold plates, the dynamics change a bit. You do need to get more flow to reject more heat, but I'm not seeing a limit in the foreseeable future.
Dale is ready with another chat.
No, I wanted to, on the two-phase and single-phase, there is a big challenge that the industry creates for itself, and that's bad-mouthing one another. It's amazing. You go to conferences like OCP and Supercompute, and they're just on each other's neck, and the customer doesn't know the difference. The customer's just listening to all these horror stories and what if and cautions. And the easiest solution is no action.
Yeah, I love that comment.
That's a
Thank
good
you
one.
so much for bringing it up. And this is something that this is the competitive nature of the industry, right? And that negative atmosphere when you're talking about competition is something that I think we really pride ourselves on that within the OCP community. But the moment that you get onto the exhibition floor and into the commercial conversations, and what I would like to say to this, to anyone who recognizes this also in their own positioning and marketing statements, the reality is it reflects poorly on the person who makes the statements. It really does. So when you go out there and you say, hey, my fluid is better than the other, and the other, you have all this trouble and you're gonna have all these difficulties, you're actually the one that is contributing to stopping the progress. And it doesn't help advancing. And this is something that we in our community take super seriously, which is why none of these presentations that you see today have any commercially driven content. We're super strict on this, and this is also within the whole confines of OCP, the way that we deal with presentation material. I so agree with you, Dale. Thank you very much for making the comment. And whenever, please, folks, to everyone out here, when you listen into a conversation like that and you hear somebody making claims like, hey, that other technology is just crap, and please correct them.
Yeah, and that's why also within OCP that we've been driving parameters of importance, for example, right? Of making sure that, hey, so customers can actually sit down and comparing different solutions that is apples to apples comparison. It's no need of saying, hey, we're so much better than the others, or anything like that. It'll be up to the customer to evaluate, right?
I also say us working so closely together and forming the relationships across the companies. I mean, we have so many fluid vendors that are participating equally in some of these. I have to say that forming the community and participating together, I think we're better than most. I think that I'm not naive. I'm sure that does happen, but I see us cooperate far more than many because we are so dependent on each other to be successful together. And I think we just need to embrace that as a community, that it doesn't matter who you are, if you have competition or not, that we all grow together just because of the nature of the ecosystem.
So we are out of time. It's time for a break. I believe it's even the lunch break, is that?
It's lunch break.
Yeah, it's lunch break. So reach out to us. Before you guys leave the room, and before you stand up and walk away, I would like to, because we have this leadership team, which is doing so much of the work, and something that most people don't really realize, nobody of us is getting paid for the work that we're doing here. We're contributing a lot of our professional time, and after we close the door of the office, when we get home, or even most of the times here in the US, before you go to the office, we spend our hours in the community trying to provide guidance, and especially all the volunteer leadership. I would really like to ask you to give an absolute grandiose applause for all the volunteers that are leading this work effort.
And I'll even say stand up. We have a ton of our volunteer leaders.
Take it. Right, because these guys are making it all happen, and we're happy to serve. This is super exciting. We love engaging with you. I hope you're going to have a great meal and the rest of the day.
Thank you
And come
so
back.
much.
Thank you. Thank you, everybody, for
Don't forget that.
sharing with us.